All right, so today we are taking a look at the quadratic formula. This is something new for us, so there might come a time where using our factoring or that completing the square and other methods might not work to figure out the solutions for our quadratic formula, for our quadratic equation, and so that's where the quadratic formula comes in handy. So there's a couple of easy steps. This right here is the quadratic formula, so you might want to highlight that. I've got my handy highlighter here. X equals negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. Now remember from when we talked about square roots last time that we always have plus or minus now that we are finding the different solution types that we might have, and so we want to keep in mind that plus or minus in between our negative b and the square root sign there. So first thing that we want to do in order to use the quadratic formula is make sure that our equation is set equal to 0 and written in standard form. So that's the main thing. So standard form, remember, is highest exponent first. And so our equation here is already done for us. We've got x squared minus 5x minus 36 all set equal to 0. So we don't have to do any extra steps for that one. The next thing we need to do is figure out what are the a, b, and c. So normally for a quadratic equation, we would say ax squared plus bx plus c equals 0. So for our equation here, we want to find what is the number for a, b, and c. A is whatever is in front of x squared. If there's no number there, it's 1. B is whatever is in front of x, and if it's negative or says minus, make sure to take that with it. So this is a negative 5. Same thing for C, except for it's the thing without any x's, and it has a minus in front, so we would say it's negative 36. So now that we've identified all those pieces, we want to take and plug them into our formula. So we've got x equals negative b, so the negative of negative 5, plus or minus the square root of negative 5 squared, that's b squared, minus 4 times a, which is 1, times c, which is a negative 36. And that's all divided by 2 times a, which is 1 in this case. So we'll want to do a little bit of simplifying. I know that negative times a negative will make that a positive 5, plus or minus the square root of, let's get this down to just be one number. So negative 5 squared is 25. Negative 4 times 1 is still negative 4. But times a negative 36, let's see, multiply those together. That would give you what? Positive 144, I believe. Yeah. And then 2 times 1 is 2. So we can still write that as over 2. And I'll take 25 plus 44, 144. And that would give me 169. Now, hopefully you still have that list of perfect squares. If not, you might want to make a new list, write one out, or print one, whatever it might be. If I take the square root of 169, that's actually a perfect square. It's 13 squared. So now I have x equals 5 plus or minus 13 divided by 2. So now I have two different options here. I can either have 5 plus 13 divided by 2, or I can have 5 minus 13 divided by 2. If I add 13 to 5, that would give me 18. Divide that by 2. One of my solutions is 9. 5 minus 13, though, would give me a negative 8. Divide that by 2, I would get negative 4. So my two solutions here are 9 and negative 4. And that would be the end of using our quadratic formula. As always, we want to write those solutions in curly brackets here so that we can clearly identify them as two solutions, not a coordinate point. So let's try out one of these other examples here. I'll have you do 2 examples, 1 through 6 on your own. So if you want to pause now and do that, you can. So you should have done 2 of these examples. Let's take a look now at the next page, the back side here. We want to do one of these examples with an irrational solution. So I'm actually going to do number 11, just for an example. And we want to do irrational solutions because sometimes our answers are need to be left in a radical. Okay, so I'll show you what that means here in just a second. We'll still follow those 3 same steps as last time. Our answer just maybe won't come out as nice and easy. So the first thing is to make sure that I get everything to the left side, meaning that I need to get this 20 to the other side. Since it's a positive 20, I'm going to subtract 20 from both sides of my equation. Now my equation will say x squared plus x, and 9 minus 20, it would give me negative 11. And that's equal to 0. So now I've got everything all together. I want to identify what are A, B, and C. Well, A, there's no number here, so it's 1. B, again, no number there, so that's 1. C is negative 11. And for step 3, we'll plug that into our quadratic formula. That's x equals negative b plus or minus the square root of b squared minus 4 times a times c, which is negative 11. And that's all divided by 2 times a, which is 1. All right, so what we want to do now is we want to simplify this down. So I'll have x equals negative 1 plus or minus 1 squared is still 1. Negative 4 times 1 is negative 4 times negative 11 gives me a positive 44. So I have the square root of 1 plus 4 is 45. All divided by 2 times 1, which is 2. Now this is where, if you have your list of perfect squares, you'll notice that we do not have 45 as a perfect square. That is not a perfect square. So what we'll have to do is we'll need to simplify that perfect square. We'll want to list the factors of 45 and decide which one is the biggest perfect square. So you've got 1 and 45, 3 and 15, 5 and 9. Now, hopefully you would say that this perfect squares that are factors of 49 are 1 and 9, meaning that the biggest pair with a perfect square would be 5 times 9. And so if I simplify the square root of 45, I would split that into the square root of 9 and the square root of 5, which is 3 square root 5. So I have x equals negative 1 plus or minus 3 square root of 5 divided by 2. Now, this is where things are different than the last time, because last time we said that we would be able to simplify this down and actually divide it by whatever is on the bottom there. However, this time I can't take negative 1 and add it to square roots of 5 because square roots don't want to go with things that don't have the square root. They don't want to go with things that don't have the same number as the square root. So all we have to do is put curly brackets around our answer here, and that's our solution. I have 1 where it's negative 1 plus 3 square roots of 5 divided by 2. And 1, that is what happens when I have negative 1 minus 3 square roots of 5 and then divided by 2. So you could test those out. You could get some decimal answers. Let's see if I were to type that in my calculator. Now, it only works to do it this way if you are not using the like iPhone calculators, those things. You'll need something that's at least a scientific calculator to do this. So first thing, we'll do parentheses, negative 1. We'll do plus first, plus 3. Second square root of 5. And then I needed that first parenthesis to close off my square root. I need another one to say that this is all the things that are on top divided by 2. So my first decimal I get, let's just say it's 2.85. That would be rounding to the nearest hundredths. So we can do the same thing. In fact, if we use our arrow key there, we can actually just change this sign to a minus sign. And then hit enter again. And I would get negative 3.85. Kind of nice that those came out to the same decimal point. Now, you do not need to find the decimal answers. I would prefer that we leave them as the radical form. So as it says here, we want to leave them in simplest radical form in the directions. So we'll leave them that way. I just wanted to show you what those would be like as decimals because we'll need those in the future. But that is everything for today. So you'll do one more example, one between 9 through 14 here. We already did 11, so you'll want to do one of the other ones instead. And make sure that you do 2 from that front page here. So that's 1 through 6.